folded pattern studied by Koryo Miura, Japanese engineer. Studied a folding pattern, realized this could fold down into an extremely compact package that had a very simple opening and closing structure. And he used it to design this solar array. It's an artist rendition, but it flew in a Japanese telescope in 1995. Now, there is actually a little origami in the James Webb Space Telescope, but it's very simple. The telescope is going up in space. It unfolds in two places. It folds in thirds. It's a very simple pattern. You wouldn't even call that origami. They certainly didn't need to talk to origami artists. But if you want to go higher and go larger than this, then you might need some origami. Engineers at Lawrence Livermore National Lab had an idea for a telescope much larger. They called it the eyeglass. The design called for geosynchronous orbit, 25,000 miles up, 100-meter diameter lens. So imagine a lens the size of a football field. There were two groups of people who were interested in this: planetary scientists who want to look up, and then other people who wanted to look down. But whether you look up or look down, how do you get it up in space? You got to get it up there in a rocket, and rockets are small. So you have to make it smaller. How do you make a large sheet of glass smaller? Well, about the only way is to fold it up somehow. So you have to do something like this. This was a small model, folded lens. You divide up the panels, you add flexures, but this pattern's not going to work to get something 100 meters down to a few meters. So the Livermore engineers, wanting to make use of the work of dead people or perhaps live origamists, said, let's see if someone else is doing this sort of thing. So they looked into the origami community, got in touch with them, and I started working with them. And we developed a pattern together that scales to arbitrarily large size, but that allows any flat ring or disc to fold down into a very neat, compact cylinder. And they adopted that for their first generation, which was not 100 meters, was a 5 meter. But this is a 5-meter telescope, has about a quarter-mile focal length, and it works perfectly on its test range, and it indeed folds up into a neat little bundle. Now, there is other origami in space. Japan Aerospace Agency flew a solar sail, and you can see here that the sail expands out, and you can still see the fold lines. The problem that's being solved here is something that needs to be big and sheet-like at its destination, but needs to be small for the journey. And that works whether you're going into space or whether you're just going into a body. And this example is the latter. This is a heart stent developed by Zhang Yu at Oxford University. It holds open a blocked artery when it gets to its destination, but it needs to be much smaller for the trip there through your blood vessels. And this stent folds down using an origami pattern based on a model called the water bomb base. Airbag designers also have the problem of getting flat sheets into a small space, and they want to do their design by simulation. So they need to figure out how in a computer to flatten an airbag. And the algorithms that we developed to do insects turned out to be the solution for airbags to do their simulation. And so they can do a simulation like this. Those are the origami creases forming, and now you can see the airbag inflate and find out, does it work? And that leads to a really interesting idea. You know, where did these things come from? Well, the hard stent came from that little blow-up box that you might have learned in elementary school. It's the same pattern called the water bomb base. The airbag flattening algorithm came from all the developments of circle packing and the mathematical theory that was really developed just to create insects, things with legs. The thing is that this often happens in math and the science. When you get math involved, problems that you solve for aesthetic value only, or to create something beautiful, turn around and turn out to have an application in the real world. And as weird and surprising as it may sound, origami may someday even save a life. Thanks.